Welcome to breadboarding. This is video 12 in the Nanocomp breadboard video controller series, and in this video what I'll be doing is extending the 640 by 480 VGA 2-color graphics that we developed in the previous video, and I'm going to try and get a Lunar Lander program working on this on the 6809. Not everyone may know, but Lunar Lander is one of the first high-resolution graphics games that was made available by Atari in 1979. This is a screenshot of it. This is one of the first games that used vector graphics as opposed to bitmap or raster graphics. In fact, the field manual for the Lunar Lander cabinets themselves, which is available on Wikipedia, has a section explaining the difference between a raster type game, which is probably what we would know. Most PC games these days are all based up on raster images on the display, lines of display, and explaining what the XY type game was. And the interesting thing about this is, in fact, the CRT tube, the cathode ray tube, was controlled in an XY manner rather than in a classic TV raster line manner, and this meant that it could plot XY vectors on the screen much more efficiently. And in fact, you can see here that the resolution of this at the time was incredibly high, considering this is 1979. So this is 1024 by 768. So this is what became XGA resolution probably another 10 or more years afterwards. The IBM PC wouldn't adopt XGA until some of the later PS2 machines in the late 80s, early 90s. So the fact that this vector type game was capable of doing a resolution effectively of 786,000 bits as opposed to the more common at the time 61,000 bits from the 256 by 240 line. So this was really quite an advance forward. And the Wikipedia article also links to this particular summary of the history of Lunar Lander. This article itself is now 14 years old, but actually covered the history of the Lunar Lander from the very early stage of the late 60s, where it was very much text-based game where you type in the amount of fuel to burn and it would do calculations of how high you were and how fast you were going. And I myself did a very simple version of this program on a TI 57 50-step programmable calculator when I was at school. And this article takes you through all the various stages of the Lunar Lander game until the arcade game from Atari was released in 1979, which was really quite groundbreaking for the time. But this is quite interesting from the point of view of the history of it. And in fact, the history of Lander was kind of cut short somewhat because the Asteroids, which was released shortly after Lander, was so popular that in fact the first couple of thousand Asteroids cabinets were actually released in the Lunar Lander design cabinets, and the success of Asteroids effectively stopped any more Landers being sold for some time. So Lander's got a fondness in my heart. I remember playing this and being absolutely blown away by it when first sort of started playing it many years ago. So Lander is available on the MAME games emulator platform. So what I'm just going to do here is to show you how you can run this. So here are a load of the links. So if we click on these, then this will take us to a site where you can download. This is the version Rev 1 of the Lander game. So if we download the zip file that's available there, then the same site includes a compatible emulator. So if we download the 64-bit 02 RAR there and you expand that, say, into a folder, such as into your temp folder, and then there was also a Rev 2 version of the Lander game, and this particular link here takes you to the Rev 2 version of that. So if you download the two zip files here, and what you would then do is to copy these down into your temp folder. So I've got mine under the main folder here, and then underneath here there is the ROMs, and you copy the Lander zip files into there. So you see that Lander 1 is Rev 1 and Lander is the later Rev 2 version. And then to run up MAME, all we have to do is to click on the executable there. When we first run this after copying the ROMs in, you do need to press F5. So F5 will actually start a game search, so it will re-scan the ROM folders to see if there are any extra ROMs and things we need. So once it's stopped scanning for the ROMs, we can now see that we've got Lunar Lander Rev 2 here, And if I just double click on this, it will start it up. Now when it first starts up, what we do need to do is to press 5 to put coins in and press the 1 key to start this. So I'll just add a bit of fuel there and then press 1 to start. So to control this, we use the left and right arrow keys to rotate the lander, and then the control key controls the thrust, and then we can speed things up. We can see that the horizontal speed and the vertical speed on the top there, and what you'll notice is that there is a certain amount of drag. I'm not quite sure how you have drag in a vacuum, but you can see the horizontal speed will actually reduce over a period of time, so you can almost sort of drift onto the landing pad. So we're just going to land this down here. Now you can see here that there is a little bit of a sort of can see the pixel sort of moving as this lands. I don't think it's probably quite as smooth in a bitmap screen like this as it probably was under the vector graphics. And then the spacebar key will give you an emergency boost. So if you're about to crash, hit the spacebar and it will give you kind of an emergency boost and will straighten things up. So if you had a horizontal velocity, it would actually change the horizontal velocity to 0. And we need to land the lander at below a certain speed, and with needs to be level. If we try to land with any sort of incline on the lander, then it would, there we go. And if you land too hard, then you get an appropriate message. So that's the MAME running the lander, and you can, what I have done here is taken some screenshots, particularly of the lander when it's at the sort of smaller mode at the top of the screen, and then when we actually get closer to the ground, then you'll see that it will then zoom in as a slightly larger lander. So I've taken some screenshots of these, and I'll also be looking at a modern web-based version of this. This should then go into, there we go, so you can see a larger version of the lander. If we crash, then explode into lots of pieces. So that's MAME. It's fairly straightforward to download. I would make sure you download the MAME that comes with the site where the lander is, because it's been made to work with the ROMs that they provide there. So that was MAME, so you can have a look for this yourself and have a little practice. What I'm going to do now is to look at some of the other links here. There is a YouTube page here where there are examples of using the lander. I suspect this is probably using MAME, or it could be the original, copies of the original. But so if you want to, you can actually have a look at the video there, and I've left the link in the description below. I was looking for some C source code to run on the Nanocomp, but to convert to the Nanocomp, a bit like I did with Tetris. Couldn't really find any. What I did do though was came across this project. So the Lunar Trails Dublin Science Gallery project was actually an artwork that was done in the Dublin Art Gallery. This involved an art installation that actually provided a web-based version of the lander game as well as the cabinet in the exhibit, and it traced the paths of the various people playing the lander game actually on a display there. But the interesting thing about this is there is a version of the game available at this link here, which is a JavaScript version of the game, and you can see that it's pretty accurate to the original. In this particular one, it uses the up arrow key for thrust, but you can sort of see that it looks reasonable, and just let it fall down. Now what I first did is I've taken some of the code from here, because this was using vector line drawing operations similar to what I did in the previous video, where I was drawing sort of lines and things using algorithm for efficient line drawing. And what I did first of all is tried drawing the ship. You can see here it looks a little bit clearer here. This one I would say is a little more difficult than the main version to land, but this is all written in JavaScript, and so it means that it will be a little bit easier to convert into running into C. It's not 100% the same, but a lot of the design aspects could be converted into C more easily. So this is the JavaScript version. So if we just land this, There we go, perfect landing. So I downloaded the source code for this. It was just, from the web browser, just the resources. And the interesting thing here is the overall game starts from the game.js with initialization and various things. There's quite a bit in here for sending the current position to the art exhibit. So there's quite a lot of messaging in here for sending the current state of the game so that it could maintain the art installation. So if you see any stuff in there, that's what it's related to. And the interesting thing is here, there is the lander object here has all the shapes to actually draw. This defines all the shapes to draw the craft in various sort of using lines, rectangles, and move to a particular position. And it also includes landscape data. So this setup data puts in all the XY coordinates for the landscape. And what we'll see is I've taken some of this and I've used it in the C program to see whether or not we can reproduce the sort of graphics that we need for the Lander game on the Nanocomp on 6809. So this is the Lander source code that I've started with. What I did was took the demonstration program that I had from the previous video. So this was drawing lines and circles and things on the VGA 640 by 480 display. What I have done here is enhance this a bit. So there's a few things here. I've added some very basic sine and cos functions in here. So this is effectively sine and cos times 1,000 for angles. So I've done angles every 18 degrees from plus or minus 90 degrees, which gives the right number of intervals for rotating the lander. The clear screen graphics is very similar to what we had before. I have made it a little more efficient than it was previously, so this does run a bit faster now. I've also incorporated the initialization code. So this provides the CRTC register values for the 640 by 480 display rather than having to run the separate assembly language program. And this also does some of the setup and that's needed and defines the graphics color to be white on black. Then there's a plot point routine, which is very similar to the one we had previously. I've not really done any optimization to this. So this is the thing that works out which pixel needs to be set on every byte on the screen memory map. Then there's the Bresnan's line algorithm draw line that we produced in the previous video. And there's also a circle algorithm, which we don't need for the moment. And those are some of the leftover bits from the previous examples and previous video. So this is then the draw lander. So I've got a large lander and a smaller lander. Now to start with, what I did is I just took the code out of the JavaScript here. I just put this in as comments so I could see what it was doing. So I was drawing the individual lines like this. But then what I wanted to do is to be able to rotate the image. So what I did is was checking one of the sites that I'd used for the original line drawing and circle drawing, and this includes a whole section on rotation. It's basically involved in doing sort of matrix calculation with cosines and sines. And when you get down to the bottom, there's a sort of a slightly easier to consume. So this basically means that you combine the x and y values with cosine and sine for a given angle, and it will rotate those coordinates to whatever you want. So what I've done in here is I defined the lines that made up the lander and put that into an array. And that meant that all I needed to do was initially just to draw the line out of the array. So rather than requiring all these hard-coded values, there's just a single line here. But then what I've done is I've extended it now to include the rotation. So you can see here, we've now actually got rotations going from the first angle all the way around to 10 or 11. So this is going through the plus or minus 90 degrees. And what it's going to do is a very crude recalculate where these individual lines that are drawing the lander are going to appear. So there's also then similarly almost the same, but the small lander is more for when the whole of the landscape is displayed, we need a smaller lander. So that's a similar thing, but done with slightly smaller dimensions and with the same rotation code. And then finally down here, the X and Y coordinates that we had in the JavaScript source code from that exhibit for the Dublin Science Gallery. What I've then done is just drawn that. I did have to change the coordinate system because I had calculated the values based on y going positive from the bottom to the top, and in fact obviously on screens we need it going from 0 at the top down to 479 at the bottom. So that's the code. Apart from what I've also done is I've enabled the printing output from C to go to a serial port. So what I can do now is to actually put debug messages and things to output to the serial port and be viewable in the terminal emulator, so that it doesn't mess up the display whilst actually running programs and things. So at the moment I've just got a very simple test in there, and then there's basically 2 calls to this. One to do the larger lander, which will draw it in all rotations across the screen, and then draw the smaller lander a little bit below it. So that's what it's doing at the moment. Not very sophisticated, but what I'm trying to do is to work out how fast can I draw the actual craft, and also can I actually get the craft to look sort of reasonable when rotated, and then what we need to do is to work out how fast we can get it to work so that we can actually make this a workable program. So what I'm going to do now is to compile this. So I've got Ubuntu Windows subsystem for Linux. So if I just run the compile there, I've switched on the Nanocomp and it's already in load. So there's a few warnings there, but nothing that's particularly important. And now what I'm going to do is to send the file down to the Nanocomp, which will take a little while. And when we run this, what I will be able to do is to show you that we can now get debug messages over the serial port. It does slow the execution of the program down slightly, but when debugging that's not really a problem. It just allows us to get a more granular information being output as the program actually executes. So we'll just wait for the Nanocomp to finish loading there. And then what we'll do is to go into the VGA screen share. So here's the VGA screen share. The program's loaded. So all I'm going to do now is to run this. It starts at Go 1000. You can see the clear screen, not quite as fast as the assembly language clear screen, but it's much faster. So this is the larger lander first appearing at the top here, and you can see the one in the middle is the one that we really started with, the one which is vertically upright, and then the lower one is our smaller version of the lander, again being rotated. Now the smaller one doesn't look great at these resolutions, and then finally you can see the landscape as it's been drawn based on the X and Y coordinates. And in fact, when I match this up against a screenshot from the original lander on MAME, the landscape actually matches almost exactly. So the landscape is a pretty good match. But these landers are based on the original JavaScript code that was drawing the lander, and obviously it's way too slow to be able to use during the game. What I've been thinking about is how I could make these a raster image perhaps, and with the different rotations, perhaps store these in memory so that I can then just sort of blit them onto the screen much more quickly. We don't have to do all the calculations to working out how the lines are drawn and how to rotate them. If we actually just saved them in memory, we'd be able to update the screen very much faster. So what I'm going to show you now is I've taken some of the screenshots that I took from the main version of the game, and what I've done is had a look at doing those in the font editing program, just because it's quite a neat way of actually doing the pixels and working out what the byte values for the pixels needed to be. So I'm just going to show you that. So frapped is a utility, and we first just need to go into DOSBox and mount C as C DOS. So DOS is the folder on my main Windows drive, and if I now go to the C drive, we can see that I've got the fonts on there and also the old Tetris programs. So I'm just going to run frapped. And in fact, what I've done previously is I modified this. What I'm going to do is load font. I've called it Lander. So if I navigate down here, there we go. So this Lander should allow us to, we have a look at the top here. So you can see here that what I've done is I've got a small lander here, which I actually printed out the screenshots from the MAME game and sort of try to work out what the various combinations were. So you can see here both sides of the smaller character here in the font definition here, and then for the larger lander you can see that this is made up into, the top is made up in two halves, and then the bottom is largely in two halves, but then because it's a little bit wider there is a little bit of leg sticking out. Now you can see from the right hand side here that the lander probably looks a little bit cleaner and a little bit better. So what I'm going to do is to update the code to use this pattern rather than the one that came from the JavaScript, and this is much truer to the original. And then I'm going to feed those into the revised version of the program and see whether or not the rotations look any better. And hopefully the rotated versions of these landers will look a lot better. And what we'll be able to do is when we run up the program, what we'll do is we'll pre-calculate all of those rotated versions of landers, store those in RAM, and then what we can do then is when we need to display them, we just need to chuck all the bits from the memory out to the video memory, and we should be able to do that a lot quicker than we can with all of the calculation of all the angles and the lines and drawing lines and things. So that's where I got to for part one. In part two, what I'll be doing is revising the design of the landers to be more like the captured versions from MAME that I've got, and then to try pre-calculating the rotated versions of the lander into memory and seeing how fast we can update the screen so we can see whether or not we can do it fast enough. I'll also be doing an analog to digital converter for a joystick. I've got an analog joystick which I'd like to use for controlling the lander. The keys aren't particularly easy to use for it, so particularly the keypad on the Nanocomp is a bit clunky. So I'm going to try and design a circuit to convert the analog XY signals from the joystick into digital signals for up, down, left and right. And then what we'll be doing then is trying to put that together in the final version of the program and see if we can make a half reasonable Lunar Lander game using the 6809 and our VGA graphics controller card. If you don't want to miss out on future videos, please hit subscribe. If you found it useful, please hit like, and thank you for watching.